In this tutorial, we're going to conclude integration by looking at integration by parts. We've already done the first part of integration by parts, and this is now the conclusion, just to cement the concept. If you haven't yet accessed that first video, you can just check on our channel, that is Meticulous Hub. You just type integration by parts and add Meticulous Hub. The video will come for the first part of integration by parts. So let's now dive into answering some questions. So the first question I have is, find the integral of x squared okay. Let's first do this one. E to the power x sine 2x. So how can you integrate this kind of a function? In our first video, we mentioned that whenever you are integrating a kind of function in this format, you use what is called integration by parts. So integration by parts has a certain formula which you need to apply. Let's say you want to integrate a function of a kind u. So integral of u dv. The formula which you need to apply: first you multiply u by v, then you subtract the integral of v du. So du simply means the derivative of u, and this v simply means the integral of dv. So that is the interpretation. So let's now do this question. So from this question we have, it's best that we make sine 2x as our u. E to the power x is very stubborn. Even if you integrate or differentiate it, it won't change. So for this one, it's advised that we take it to be our dv. So let's say, let u, our u be equal to sine 2x, then our dv will be equal to what remains. So what remains is e to the power x. Then, mind you, we're integrating this with respect to x, so it is e to the power x dx. Then at this point, we're going to find what is the derivative of sine 2x. So whenever you're differentiating sine 2x, we first start by differentiating what is attached to the trig function, which is sine. So derivative of 2x is just a 2. Then you differentiate the entire function. Now derivative of sine x, that will give you a cos 2x. So we've differentiated that. Then for this one, we're going to integrate. Dv is the derived function. Now let's integrate v. So we're going to say v will be equal to the integral of e to the power x remains e to the power x. Then at this point, we're going to apply the formula, which is, when you are given the integral of u dv, you say this is equal to uv minus the integral of v du. Now let's do the substitution. So we're going to do the substitution. Okay, let me just write this here. So what we have is uv minus integral v du. So we do the substitution. Our u is sine 2x. Then our v is e to the power x minus the integral of v, which is e to the power x, then multiplied by du meaning that the derivative of u, and that is what we found to be 2 cos 2x. Okay, so after getting this, we can now evaluate. So we're going to say this will be equal to I can even write it here. So this will be equal to e to the power x multiplied by sine 2x, then minus integral of e to the power x, then multiplied by 2 cos 2x, like that. Okay, so I can now integrate this function. So to integrate that function, this is what I'm going to do. Let's have integral of e to the power x, integral of e to the power x, then 2 cos 2x. So even this one, I'm going to use integration by parts. So what I'm going to say is my u will be 2 cos 2x. Okay, that will be my u. And mind you, here once we integrated, we differentiated sine 2x, right? And that gave us that. Okay, so here my u will be 2 cos 2x, then my dv will be equal to e to the power x, then dx. Then my u prime, meaning that derivative, will now be the derivative of cos 2x. Okay, that is negative. Okay, so it will give us negative. Then we start by differentiating 2x, and that will give us 2. So 2 multiplied by the 2 in front there, it will be 4. So now the derivative of cos 2x, it is negative sine 2x. So this will be our derivative. Then here we integrate e to the power x, will just be e to the power x. I can now substitute. So this will be equal to, what is our u? Our u is 2 cos 2x. Then what is our v? Our v is 2x minus the integral of, what is our v? Our v is e to the power x. Then our du, so meaning that the derived, or the function which we have differentiated, which is negative 4 sine 2x, like that, then dx. Okay, so after having this, let me get rid of this part. So I can now substitute there. So it will be integral of e to the power x sine 2x dx will be equal to e to the power x sine 2x. Then where there is integral of e to the power x 2 cos 2x, I'll substitute this which I found. Okay, so it will be minus, then I do the substitution, minus 2 cos 2x, then e to the power x, like that, then minus integral of e to the power x, then so negative times negative, there is negative there and there is negative there, so it will give us a positive, so it's same as plus e to the power x, then we'll have sine 2x. Okay, so that is what we are going to have. So we can see that something is similar here. We have e to the power x sine 2x, and this is what we have here, e to the power x sine 2x. So we can take this to the other side. Okay, so what we are going to have is e integral of e to the power x, then sine 2x, sine 2x, then dx. This is minus, so when it goes to the other side, it will be, this is plus, I mean, it will be minus, again, integral of e to the power x, then sine 2x. This will be equal to e to the power x sine e to the power x sine 2x, then minus e to the power x cos, okay, there is 2 there, so I can say 2 e to the power x, then I say cos 2x. Okay, like that. Then I can just add now the two. In fact, some subtracting. We have, so here there was 4, sorry, it was 4, it was 4, so when it goes to this side it will become negative 4. So if we subtract, we'll get negative 3 e to the power x, so negative 3 e to the power x, then sine 2x dx is equal to e to the power x sine 2x minus 2 e to the power x cos 2x, like that. Now to find what I was looking for, which is integral of that, so there was integral here, integral of e to the power x, I can just divide by negative 3 here, even here by negative 3. So I'll now get what I want, which is the integral of e to the power x sine 2x dx. This will now be equal to that, we'll cancel with that, which is negative 3 divided by negative 3 to just give a 1. So we'll have e to the power x sine 2x minus 2 e to the power x cos 2x over 3, which is negative 3 over negative 3. So that is our answer. So we've found the integral of e to the power x sine 2x with respect to x. We've integrated. Let's look at another question. Let's say you've been given to integrate x square, maybe x square, then e to the power negative x with respect to x. So I'll need to find my u. So I'll say let u be equal to x square, then derivative of u will give us 2x, then let dv be equal to what remains, it is e to the power negative x dx. Then my v, the integral, now I'll say the same thing, e to the power negative x, same expression, now divided by the derivative of negative x, which is just negative 1. So in short, what I'll have is negative e to the power negative x. Now I'll do the substitution in the formula which we have. When you are given integral of u dv, you just say this is equal to uv minus integral of v du. At this point I can do now the substitution. This will be equal to, my u is x square, okay, my v it is negative a to the power negative x, like that. Then minus integral my v again, negative e to the power negative x, like that. Then my du is simply 2x. We are integrating this again to the with respect to x, so I can get rid of this. I'll now do the integration this side. So this is giving me x squared, then multiplied by negative e to the power negative x, like that. Then minus integral of negative e to the power negative x, then 2x dx. So now integrate this function. So to find the integral of that, I'll say my u, so what I'm finding is this. I want to find the integral of negative e to the power negative x, then multiply by 2x, like that, with respect to x. So I'll say my u will be equal to 2x, my dv rather, my dv will be equal to negative e to the power negative x. Then my u prime derivative will just give me a 2, derivative of 2x. Then my v now, and I should put dx there. My v will now be integral of this, so it will be negative e to the power negative x, now divided by the integral of, derivative of negative x, which is negative 1. So it will be like that, and that will give me a positive e to the power negative x. Then I can substitute in the formula. What is my u? My u is 2x. What is my v? My v is 2 to the power negative x, like that. Then minus integral of, what is my v? My v again is e to the power negative x, multiplied by my du. My du, it is simply a 2x, not really 2x, but it's just a 2. Then dx. So this is what I'm going to have. Okay, so this is what I'm going to have. But you see, I can again find the integral of that. Okay, so if I find the integral, if I find the integral of e to the power negative x to dx, I'll simply get, so my u will now be a 2, my dv will now be e to the power negative x, then my u prime, derivative of constant is equal to 0, my v will now be e to the power negative x. Then I'll say integration of this will be, what is my u? My u, it is 2, my v, it is e to the power negative x, minus integral of, what is my v? E to the power negative x, then multiplied by my du. Du, it's simply 0, so I'll have 0 here, and 0 multiplied by everything will just be 0, so I can erase just this and say this will give me 2e to the power negative x. So this is what I'm going to have here. So I'll say minus 2e to the power negative x. So this is what I'm going to substitute there. So what I'm going to have, integral of integral of x squared e to the power negative x dx will now be equal to x squared, then negative e to the power negative x, like that, minus, when we get to integrate that, it gave us this. Okay, so I'll say minus open brackets 2x e to the power negative x, like that, then minus 2e to the power negative x. Now I can just conclude to say this will be equal to negative x squared e to the power negative x minus 2x e to the power negative x, then it will be plus 2e to the power negative x. So this is my final answer. So basically this is what you need to do. So in a case whereby you are given e to the power x, it is more advised that to make e to the power x to be dv, because no matter how you can differentiate e to the power x, you won't be able to get 1 at any point. So make it dv. But in a case whereby you have something like ln x, it is advised that to make this ln x to be your u, because once you differentiate ln x, it will give you 1 over x. But it will be very difficult for you to integrate it unless you know some formula you need to apply, also some concept you need to apply. But it's best that you take it to be u. So this is the end of integration by parts. You can watch part 1 of this video on integration by parts, where we did the introduction, solved some questions, and this is just to cement the concept. Thank you for watching, and don't forget to subscribe.